All right, ladies and gentlemen, welcome back to these Athenian Stranger tutorials, where today we're going to take a look at how to find the distance between 2 points on a graph. So this is going to involve something called the distance formula, but I have to be honest with you, I don't like the way the book teaches it, because when I start hearing my own voice say the word formula, this makes me think, oh, so this is something I've got to memorize and I'm never going to understand it. So I'm going to show you a more intuitive approach to finding out this distance right here, that you'll end up at the distance formula, but we're going to use something you already know. So what I'm going to propose to you is that right now there is a triangle on this piece of paper. Okay? It might not seem like it, but there's a right triangle on this piece of paper. Let me show you what I mean. Let's dot a line connecting these 2 points. Okay? Let's dot in a line right here. And now what I want to do is take my ruler or my protractor and I want to draw a vertical dotted line that goes from this top point down until we get to right here. Okay? So watch me do that. So now I've got this imaginary right angle coming up here. I'm going to take my ruler and draw in this dotted line here. No, I can hear math teachers all over the country saying, for heaven's sakes, just show them the formula. No, because that doesn't create any understanding. So follow this and you'll understand. Now I've got a little right triangle. Okay, we're going to use the Pythagorean theorem to figure this out. First of all, what is the absolute distance between right at this point here and here? Now, if you don't know that, go up and take a look at the x-axis. You go from -2 over to -5. So what is the distance in an absolute terms? The distance is 1 hop, 2 hop, 3 hop. So the distance here is 3. What is the height of this triangle? So that's the base of the triangle. What's the height of the triangle? Okay, we start at -3, -2, -1, 0, 1, 2, 3. So how many hops was that? 1 hop, 2 hop, 3 hop, 4 hop, 5 hop, 6 hop. This height right here is 6. Okay? So now what I'm going to ask you is, what is the hypotenuse of this triangle? Well, now you can use Pythagorean theorem. A squared plus b squared equals c squared. Okay? So this, we'll call this A. We'll call this B. And we'll call this C. So what do we know? We know that a squared plus b squared equals c squared. And we know that a is 3, so 3 squared, and b is 6 plus 6 squared equals c squared. Now let's remember, if I've got c squared and I want to get rid of the squared, what do I have to do? Okay, your brain should be thinking of the square root symbol. So you're going to take the square root of both sides. You're going to take the square root of c squared, and you're going to take the square root of 3 squared plus 6 squared, just like that. Okay? Let's do the inside first. What is 3 squared? 3 squared is 9. So let me draw this square root symbol again. I now have this equal to c. Okay. 3 squared is 9 plus, what's 6 squared? 6 times 6 is 36. So now I've got the square root of 9 plus 36. What is 9 plus 36? 9 plus 36 is 45. So now I have the square root of 45 equals C. Okay, what is the square root of 45? Is there an even square root? Okay, can you go through the square roots in your head? Do you get to 45? So 6 squared is 36, 7 squared is 49. We jump right past 45. So there's not some whole number square root. So what can we do? Well, now it's time to break out our old friend, prime factorization. Give me two numbers that make 45 when you multiply them together, but make one of the numbers prime. Okay? 3 is a prime number, and we know it can't be 2 because this is an odd number. So 3 is the next biggest, 3 is prime. What times 3 equals 45? Okay? Think about time. 3 times 15 equals 45. 15 can be broken down again, 3 times 5. So I can rewrite this square root as the square root of the individual pieces. 3 times 3 times 5 equals C. I have two 3's right here, so I can pull out one of them, and that cancels the 3's on the inside, leaving me 3 square root 5 equals C. Okay, so I know the distance now between these 2 points. It's 3 square root 5. Okay? There is a midpoint formula that involves you finding the coordinates of these 2 points and then taking the midpoint of that using the distance formula. I think I said midpoint just now. I meant distance the whole time. So we'll take a look at how to implement that distance formula, but this is a derivation of it using the Pythagorean theorem. So if you are not up to speed on your prime factorizations and your square root rules, this is the time to get that fixed because you're going to be seeing a lot of this in geometry. Okay, well, I hope you found this tutorial useful. And if you would please like and subscribe, leave a comment, and hit that notification bell so you're always alerted to new videos when I post them. Thank you very much.